So today in class we're going to look at function operations and composition. Function operations is just when you are combining functions by either using addition, subtraction, multiplication, or division. And most of this is really just working with combining like terms, particularly on addition and subtraction. Multiplication and division, they don't have to be like terms, but this is really where you need to start to remember your exponent rules. Okay? So if you look down here at the first set of examples, it says let f of x equals negative 2x to the 2/3 and g of x equals 7x to the 2/3. Now please remember that this part is just the name. The actual function is what is on the other side. And so example A is asking you to find f of x plus g of x. Okay? Well, that's when you take your f function and you add it to your g function. These are like terms. They're both the same variable with the same exponent, so we will add them together and our answer will be 5x to the 2/3. Subtraction is no different. We are just going to subtract those, and since they are like terms, we can do the subtraction and we will end up with negative 9x to the 2/3. Now with division, go ahead and fill out the functions. It'll be negative 2x to the 2/3 divided by 7x to the 2/3. And remember, with division, you really need to think about your exponent rules. Now our coefficients, we're just going to do what the problem says, which is to divide. These won't divide evenly. It also won't reduce. The negative 2 over 7 is going to stay as it is. And just remember, with a division problem, we subtract our exponents. Well, 2/3 minus 2/3 is x to the 0. And we know that anything to the 0 power becomes a 1, and so your final answer will just be negative 2/7. If we look at the domain of f and g, what this is asking for is what kind of numbers can you plug into the value of f plus g? Well, we already figured out that that's 5x to the 2/3, okay? What you really need to focus on is what type of root is this part, okay? The 5 is really not going to affect it. We're really looking at the x to the 2/3. Now, if you remember from our radicals unit before, x to the 2/3 is really the cube root of x squared, okay? And it's wanting, basically what it's asking is what kind of x's can you cube root? Well, cube root, because it's an odd root, we can take the cube root of both positive and negative values, which means that our domain is going to be all real numbers. However, if this had been the 4th root or 6th root, remember you cannot take an even root of a negative number, so that would have changed our domain to x has to be greater than or equal to 0, or only the positive values, okay? So just remember, when they're talking about the domain, they're asking you what kind of values can you plug in for x, and in this case it would be all real numbers. Example E, it's asking you to multiply these two. So we're going to take negative 2x to the 2/3 times 7x to the 2/3. Again, think about your exponent rules. It is a multiplication problem, so our coefficients we are just going to multiply. And when it's a multiplication problem, we add our exponents, and 2/3 plus 2/3 is going to make 4/3. Just a note, please remember on any other problem, if you had fraction exponents and they didn't already have a common denominator, remember, to be able to add fractions, you must have a common denominator. Just keep that in mind. You go to the next page. The second part of what we're covering today is called composition. This is when you actually insert one function into another and calculate the value. And I'm going to show you a couple examples. You go down here to the example. It says let f of x equals 2x minus 7 and g of x equals x squared plus 4. It says what is the value of g of f of 3? Well, with these composition functions, what you're going to do is you're going to start with the innermost and find that value, and then you plug that into the outer function. So for this one, the first thing I'm going to calculate is what is f of 3? In other words, what's the value of my f function when I plug in a 3 for x? Okay, well, using my f function, which is 2x minus 7, I am going to replace the x with a 3, and I'm going to find the answer. Well, 2 times 3 is 6, and 6 minus 7 gives me negative 1. Now that I have found this value, I am going to plug that value into my g function. And so now what I'm going to calculate is what is g of negative 1. So I'm going to go to my g function and I'm going to replace the x with a negative 1. Negative 1 squared is 1, and 1 plus 4 gives me a 5. That is your final answer, so the correct answer choice would have been D. Let's just look at a couple examples down here, and then I'm going to give you a little different situation as well. So for example, in example A, it wants you to find g of f of 5. So we first need to find f of 5, so I can plug that value into g. Well, f of 5, here is my f function, it's 3x minus 8. I am going to replace the x with a 5 and find the answer. Well, 3 times 5 is 15, and 15 minus 8 is 7. I am now going to take that value and plug it into my g function. So I'm going to find g of 7. G of x is 2x squared. I'm going to replace the x with a 7. 7 squared is 49. And so the final answer will be 98. You do have to follow your order of operations. You do need to square the 7 first and then multiply by 2, because that's what the order of operations tells you to do. Okay? And so this would be your final answer. Let's go ahead and skip example B. Let's look at example C. You can plug a function back into itself. This one is asking you to find f of 5. Well, I'm going to first start with the innermost function. I think I forgot a parentheses. I'm going to find f of 5. Well, the value I get when I plug in a 5 for x in my f function, we already calculated this, ended up being 7. So I want to take that value and plug it back into f again. So now I'm going to calculate f of 7 to get my final answer. Well, that will be 3 times 7 minus 8. 3 times 7 is 21, and 21 minus 8 is 13, and that will be your final answer. Now, so far, all of these have actually asked you to plug in a value, but I'm going to skip this one. What if I give you this one instead? What if I asked you to find, we're just going to call this example D. What if I asked you to find f of g of x? Okay. What that is basically stating is take your function, your g function, and I want you to put that whole function in for x in f. Okay. Well, our g of x function was 2x squared. So I'm going to go to my f function, and wherever I see an x, I'm going to replace it with 2x squared. And so here's what that ends up looking at. It would be 3 times 2x squared, and then minus 8, and I will just simplify what I can. The only thing I can simplify here is I can do 3 times 2, and my answer will be 6x squared minus 8. However, if you look at it the other way, what if I asked you to find g of f of x? Okay, this is saying take your f function, which is 3x minus 8, and plug it into your g function. So wherever I see an x in my g function, I'm going to replace it with 3x minus 8. And so this is what I would have. Now, I want you to be careful on this because, again, think about what this means. 3x minus 8 squared means that you have 2 of those. You cannot distribute the exponent. You must do it this way. So you would do the FOIL method or the distributive method, and then you would multiply everything times 2. So from here we would get 2 times, we'll have 9x squared minus 24x minus 24x plus 64. And then I would multiply everything by 2, 18x squared minus 48x minus 48x plus 128. And then I can combine my like terms in the middle. And so my final answer will be 18x squared minus x plus 128. Okay, but if you have to square or cube an expression, remember that you cannot distribute powers. You have to do the distributive method.